So the question was how to know when we're forming pi bonds. And so pi bonds only form, we're only going to have a pi bond when we have a double or a triple bond. So anytime we have a double bond, we're going to have one sigma and one pi bond. So double bonds in a double bond, we're going to have one sigma bond and one pi bond as well. And that's why, that's really important, why this carbon is sp2 hybridized, and that's sp2 hybridized, and that's sp2 hybridized because to make our sigma bond in that carbon-carbon double bond, right, our carbon-carbon sigma bond is sp2 to sp2 orbital, but our carbon-carbon pi bond is p orbital to p orbital. So that's why it's important that those carbons that have a double bond are sp2 hybridized because they need that unhybridized p orbital to form that pi bond. Nope. So to be a triple bond, we would just need to have two unhybridized orbitals. So like in acetylene, for example, right, we're sp hybridized because we're linear. So both of those carbons are sp hybridized, and that means they each have two p orbitals. They didn't blend together. So we can use both of those p orbitals to make each of the two pi bonds, because in a triple bond, we still have one sigma bond, but now we have two. So a triple bond, we're still going to have one sigma bond, and now we're going to have two pi bonds in that triple bond. So that's why we're sp hybridized. The cases where you're going to see a d orbital overlapping with a p orbital are going to have to be with an element that has d orbitals. So carbon doesn't have d orbitals, right? Because carbon's in the second row. So that phosphorus example we saw, or the sulfate example we saw, right? Both of these, the phosphorus, the sulfur, both of them are sp3 hybridized because they've got 4 electron domains. They're tetrahedral geometry. But because they're sp3 hybridized, we've blended together my s orbital, we've blended together our p orbitals. So the only orbitals they have left to form a pi bond would be the d orbitals. So in these cases with phosphorus and sulfur, then we would see, okay, a d orbital from sulfur or a d orbital from phosphorus overlapping with the p orbital from oxygen to form that pi bond. Yeah.